Aaron Master holds a PhD in electrical engineering from Stanford University, where he did his work at Karma. He's held positions as a research engineer, product manager, and also director of user experience at SoundHound. Now, Aaron's a platform manager at Dolby Labs. He's a great guy, he's committed to helping students, and he's passionate for research and our industry.
My name is Aaron Master. I have a PhD from Stanford University in electrical engineering, where I was a graduate student at Karma. I worked for SoundHound Inc. for 6 years, and I currently work for Dolby Laboratories, where I've been for 2 years. So I was a huge music nerd in high school. I was a very serious classical saxophonist. Not that there's a whole lot of classical saxophone in the world. And I actually went to music school in college, and I picked the university I attended based on it having a really strong music school, which is the Eastman School of Music, and also having an engineering program. So this was the University of Rochester. So I did a double degree in electrical engineering and music, not at the time realizing that you could actually kind of combine these. And about senior year, I saw a poster actually in the hallway at Eastman advertising that Stanford had a program at this place called Karma, where you could basically do engineering for music technology. I realized the scope of problems that were out there in music technology, that you actually could do a master's or a PhD in electrical engineering signal processing for music and speech applications. I was really excited about that, so I figured out what I wanted to do, and I finished that master's and then went to Stanford at Karma for my PhD, which I completed about 6 years after that. Can being a musician help you at music tech? I would say there's no doubt that having some basic musical vocabulary is going to make your life a lot easier, because you'll be able to speak the language in terms of knowing what you're talking about, what all your parameters are talking about. I would say there's one specific case where having a performing background was helpful, and actually was on this transcription problem I was working on, where you've got to be able to tell what someone's saying. Pretty simple task in theory, but when you actually have to do it, it's really hard, and one of those things is vibrato. If you can tell that somebody is using vibrato, then that's one note. If somebody is switching quickly between two notes, and there are a lot of songs where that happens, that's two notes. And being able to tell the difference is very key, because the two will lead to different transcriptions and different search results. So I knew from being a musician what was in the realm of tasteful vibrato or realistic, or what would be perceived as such, and that made it a lot easier to write an algorithm that would parameterize it well. So I'll just tell a couple stories that I think maybe illustrate some of the differences I noticed between academia and at least my experience at this startup. So something that would happen a lot, or at least that I experienced a lot in academia, was you read a paper and it says, well, we're going to make the following assumptions, and then we're going to work on this really cool part of a problem that hasn't really been solved yet. And then a page, paper's 4 pages long, and 3.5 of those pages are what they did around that problem, and the data and the results and the conclusion. What I found to be the case at SoundHound was there's a lot of practical stuff that has to be taken care of before something is going to work, and the problems that you are solving are not necessarily the cutting-edge, academic, mathematically interesting, unsolved problems in the field. They're like, stuff just doesn't work, and you need to work around it. One example was we had a database of songs that people had sung, and that was how we did the singing search. We searched a query against that database. Well, a lot of the songs in that database, and indeed a lot of the queries, had this buzz from the microphones that people were using. So, of course, debuzzing is sort of an algorithm you can write, and there's probably some papers on it, but it wasn't, my goal was not to go write the best debuzzing system ever made. It was to make a debuzzer that would work on all this huge database of recordings we had. Now, in the meantime, we also decided to send people microphones that wouldn't buzz. We literally, that was like one of the company's goals. So they had floor-to-ceiling boxes of microphones that they'd ordered from China that had our company logo on it that we sent to users when they were contributing to the database, and that actually helped. But yeah, my unglamorous job for a while was, to work on debuzzing. The thing that surprised me when transitioning from academia to industry was that somebody was willing to pay me to do this. And actually, that I think was also a reason I was so freaked out when I had my first sort of academic failure or failure to produce a result on the job, was I mean, somebody could have given this money to Stanford, right? Or I could have been paying tuition to do this, but no, they are paying me to do this, and I failed to do it. Amazing that this is sustainable in any way. It's okay to have a sloppy solution that works. It's okay. You know, nobody's going to come to your seminar about your solution and say that it's not as good because it cut some corners or it used a 80% effective method for one part of it. That's okay, right? And also when it's a startup, it's all about execution. It's all about get it out the door. So that is also okay.